Okay, so in the yesterday's session, we were talking about hash hash map, linked hash map, identity hash map, and weak hash map. So in the weak hash map, I was telling you like one second.
Okay, sir.
Right. So in the weak hash map, I was telling you like when you create some object and set that object to the weak hash map, and after that make that object as null. And after that, if we can see that whether that object is there or not in the weak hash map, uh, it will not be there. Of course, we cannot guarantee that at what time it will remove that object. But if you can explicitly call like this system.gc, because this means actually garbage collector will run at some scheduled time. But if you want explicitly to call that, then we can call like this system.gc. And so after that thread.sleep means every program will run in the thread. So main is also one thread. So what we are saying, call the garbage collector and wait for some time. And if I have given the same example for weak hash map and the hash map. Weak hash map, I have created this object and I set that object to this weak hash map. Again, after that, I set the object to the null, whatever I pass to WeakHasMap, and after that I call the garbage collector, and I'm making the thread to wait for some time. The same thing I did for HashMap. So both WeakHasMap and HashMap are having one object. After the setting that object, we are making that object is null. So what happened? So this is the object of WeakHasMap where it doesn't have value object, and this is the hash map. Though still the employee object we set it to null, but still it is there as part of the hash map. Yeah, yesterday we did not call this system.gc. Of course, even if we call it, sometimes what will happen, it will not call immediately. So that time you might not see the output like this, but that is the difference between weak hash map and hash map. Okay, now we will talk about the different other classes which are implementing map interface. So we'll talk about sorted map. So sorted map, there is another interface that is navigable map, navigable sorted map. Navigable sorted or navigable map? Yeah, it's navigable map. The same way we have it for set. Here also we have it for sorted map, and This is also interface. TreeMap is the class which is implementing NavigableMap. Of course, indirectly implementing SortedMap. So if you see map, this is the order: SortedMap, NavigableMap, and TreeMap. And again, same for map, hash HashMap. What is that? IdentityHashMap. And so we have seen these four yesterday. Now we will see about these three. So basically, if you see here, we have mainly these two: HashMap and TreeMap. So now, okay, so what I'll do first, see, we have covered HashMap and HashSet TreeSet, right? Now we are talking about TreeMap. What I'll do, I will, for the same object, I'll take four and I'll see. Let's see what is happening for these four. Okay. First, let me take it for HashMap. Of course, map is taking. First, let us come from HashSet. I'll take a new class so that I'll take one employer class. So assume that employer class is having employer ID, MP ID, and name. Let's take setter getter methods and a constructor for this. Okay, so I'm not taking the toString method, just the setter getter methods and constructor. Okay, so I'm creating object for that. employer is TCS. So let's say this hash set is taking, or will not take that first, okay? I mean, I'm not giving any generics. Generics means if I say explicitly employer, that means this hash set will take only the employer type of objects. So I'm not doing that. So we'll see different scenarios. Hash set dot add of employer object. Okay. Again, I'm adding the same object. So I have added the same object twice. And after that, I'm directly, instead of creating a separate object, I'm directly doing it here. Say IBM. Okay, so what I did here, I have created an object. I passed that object twice, and again, dynamically, I'm creating an object, passing it, but the values are same. Now, if I print it, okay. So how many objects we have here? This is one, because I did not give the toString method, it will not show the values. So this is one object. This is two. This is three. Okay. So it is taking three objects. It is taking three objects. So what it did, this employee object, it is treating it as duplicate. Okay. So this employer object, it is treating it as duplicate, but the other two, it is not treating it as duplicate. So you are seeing three objects. Actually, this object is also, if you see this object, contents are same, but it's a separate object. But still it is not considering it as the same object. Though the content is same, but it is not considering it as the same object. But this one, it is the same object. Let me take like this otherwise. So we have seen it for the same object. Let's take third example. I'm taking another object. I'm passing that first object reference to the second object. Okay. Now I'll pass the second object. Okay. Now same object, pass it twice, and here the first object assigned to the second object. Now after that we are adding that second object. Now if I see the result, now also we are seeing only 3, right? This is 1, this is 2, and this is 3. So we are seeing 3 objects. Okay. So what it is doing, it is uh, it is verifying based on the hash code. Okay. If I print the hash code of first object, let's print that hash code of the first object. If you see the hash code of the first object and the second object, this is the second object, right? So both are same. Okay.
Yes, sir.
So what happened internally? So first this first object is pointing to with some object, that employer object. Okay. Okay. Yeah. I mean, so not the same name. So this employer object is pointing to the some object. This is the reference. Employer obj is the reference which is pointing to the object, and that object is having values like id equals to 1 comma employer name equals to TCS. Okay. Now this reference is pointing to this object. Now what we did, the same reference we have assigned it to the second object. Now the second object and the first object, the second reference and the first reference will pointing to the same object, because first object reference we have assigned to the second of reference. So now both are pointing to the same object. So that means both are referring to the same address. So both objects are having the same hash code.
Okay, sir.
So what HashSet is doing to check the duplicates, to say like whether it is duplicate or not, it is checking whether the hash codes of those two objects are same or not. So now we have seen that those two objects hash code is same, right? First
Right.
object hash code and second hash code object is same. So that is the reason it is saying that okay, those two are duplicates. It's just taking only one. Okay. Which one it is taking? Let's see that. So of course those two are duplicates, but which one it is taking finally? It is taking. We don't know which one it is taking. I mean, from here we cannot say that, but it is taking the. I think let's see. Let's print the class name. Okay. Let's print the class name. I think the get class is enough. Let's print this. Let's see. I mean, which reference it is not saying that. Anyway, only it'll. I think it'll take the latest one because see what it is printing. The add method, what it is printing. Okay, let's print this and see which one, if it is returning anything. So first time it was printing true. Okay, I think only the first object it gets added. I think it did not added the second. So the employer of obj1 is not there. Only employer obj is first object is only there, because if you see here, first one is coming as true. That means that object gets added,
Yes, sir.
and the second one it's not added, it's saying false, and third one also it's not added, it's saying false. Okay,
Okay.
so now okay, this hash code. So every object that we are creating, it will have some hash code. Okay, now so it will be like this. So this is the, for this object, this is the hash code, and for the second one, this one.
Okay.
So like this, every object will have a hash code like this. Now internally what it is doing, while adding an object, it is checking whether the hash code is equal or not. If it is equal, then especially for hash set, but we have seen, suppose if I do the same thing for array list. Okay, let me take it for array list. Suppose if I do the same thing for array list, and I'll give the print statement for this. Now if I print it, so whatever, even if you see in the array list also, of course it is the same objects, we are seeing the same hash code because it is the same object. But if you see here in the array list, it is not treating them differently. It is not eliminating the duplicates. See 7979 79, and after that other two objects. Okay, and for the addition, where is the for addition? And if you see here for the addition, for all the three objects, though it is same, it's still added and it is written true. So though the hash code is same, but still it is taking all the duplicate objects. And the hash set, it is checking it is checking whether the hash code is true or whether the hash code is equal or not. If it is equal, then it is treating it as duplicate and it is not adding that. But there is another point here. For example, now both are pointing to the same object. Okay.
Okay.
Now, what I will do, I'll change the value from here. So employer name, I'm changing it to CTS. So actually both are pointing to the same, but I am changing the value here. But still, since it is the first object only we are seeing only the first object gets added and the second object is not added. So it doesn't matter whether we are changing the value or not. And for example here, instead of IBM, I'll take TCS and same as 1. Again 1 TCS. Okay. So actually, so now it doesn't matter whether it is same or different because anyway it's not considering this object. Okay, now I have one employer object with ID as 1 and employer name as TCS, and I'm adding two other objects. Of course it's new objects, but the values are same. Now if I print it, if you see the hash code is different but internal values are same. Okay, so that means when just only the hash code is same, sorry, when just the contents are same, multiple points are here, like in now what we have seen, content is same but hash code is different. Okay, so content is same but hash code is different. So what it is saying, objects, it is treating it as objects, treating objects as different. Okay, it is treating objects as different. But I'll take the same example. Okay, now what we have seen, the objects are different but the content is same, right? This object is different and this object is different but the content is same. So what happened, we have got different hash code for these objects. This object hash code is different, this object hash code is different, so it is treating it as separate objects. Now in the second case, hash code is same, content is also same. I mean this case, not this one, this case. Hash code is same, content is also same, then treating as same objects. Okay. Now let's see the same thing with now we have this employer object. Okay. Now let's see the same thing with the string object. Let's see what is happening. Let me take another hash set, or I'll take here itself. For now, I'll take it here. Okay, I have two strings. Okay, now what I'm doing, no. Sorry, content should be the same. Okay. Now what I'll do, I'll print the hash code for this. First string hash code. Second string hash code. First, let me print this. So if you see here, actually we have created two separate, but what happened? The hash code for those two objects coming as same. Okay, now if I add these two objects to the set, what will happen? What will happen? Since the hash code is same, now it will take only one object. Okay, hash code is same. Now the hash set, how many we have? We have 1, 2, we have this hello, 3 and 4. Okay, we have 4 objects. Of course, the string there, it is overriding the two strings, so it is directly printing the value. Whereas in our case, we did not override the two strings, so it is not printing. It's not printing the value, but it is just printing the reference name. Okay, so now what happened? We have created two separate string objects. When we add them to the hash set, it is just taking only one. It is considering other object as duplicate because the hash code is same. Okay, but we did not do anything, and the same thing we did for employer. So in this case, this is fine. Suppose if I take like this, another object with the same content. Now if I add that, what will happen? The hash code will print it. I think this is for array list. Where is the hash code? Yeah, for now I'll comment for array list. Third object. So for the third object, if you see, it is different.
Sir.
But first two objects, it is same. But the third object is different. But actually, if you see, the content is same.
Yes, sir.
Content is same, but still it is showing a different hash code. If it is a different hash code, what will happen? It will add that object. So now we will see 921, sorry, 291 object. This is another object 2. This is 1 3. This is 4. This is 5. So total we have 5 objects. So it is not treating it as a duplicate object. So that means what is happening? String is doing something. String class, in the string class they did something so that though you created a different objects, when the content is same, it is returning the same hash code. So in the employer class, we did not do that something. When we create separate objects with the same content, the hash code is coming differently. So that is the reason it is not treating it as a duplicate object. So what is that something that string is doing and we are not doing? So what is happening in the string class? They are overriding two methods. One is hashcode method and the second one is equals method. So they are overriding hashcode and equals method. Okay, now in this case, for example, if I say hello one, will it return same hash code or different hash code? Because the content is same. Okay, content is so now content is different. Now let's see what is happening. Since the content is different, because first one is hello and second one is hello one. Now we are seeing a different hash code. So we are seeing hello one and hello both. So when the hash code is same, then it'll hash code is same. That means the content is also same. When hash code is different, then content is different. But that is not the case with our class. When it comes to the string, when the content is same, though we have created different objects, for all those different objects, it is giving same hash code. And when we try to add all those different objects, it is just adding one object, and others it is considering as duplicate objects. When content is different, it is generating different hash codes for different objects. So those objects are treating as separate objects. Whereas in our case, when we create different objects with the same content, but still it is generating different hash codes. So that is the reason it is not considering it as a duplicate objects, it is considering them as separate objects. So that means we need to do something in our class to check the content. So the equals method, what it is doing by default, we have three things. One is this one, equals operator, equals method, and hash code. If it is a primitive type, okay, primitive type in the sense integer, float, long, double, or something. This equals method is checking for content. If it is a wrapper class in the sense, for example, this one, a int I equals to 10. Int k equals to 20. Now I'll say like if I equals to k. Okay. So this is checking for, in the case of primitive, this double equals is checking the content. So if it is equals method, you cannot call equals method on primitive type. Okay. Suppose wrapper classes means this one, integer I equals to 10. Integer k equals to 10. Now I can call both, like m equals to okay, and m dot equals of n, because the wrapper class also, so it's also object, so we can call double equals to or equals to. So this double equals to, when it comes to the objects, let's print it. Let's see what is happening. Okay, I mean we have already seen this with the string. Let's do the same thing with integer. It's deprecated. Okay, so if I do this, so what happened? Equals method equals method came, but the equal operator did not come. So what is happening? The equal operator is checking for the reference. So since these two are different objects, so M will pointing to one object which is having some M equals to 10. And in the second case, N is pointing to different object. There N equals to 10. Okay, where the value equals to 10. So since M is pointing to one address, N is pointing to another address, this equal operator is checking for the reference comparison. Reference comparison means the address. Since both are pointing to the different addresses, this is coming as false. Whereas here, though M and N are referring to the different objects, but the content is same because both are having 10 value, it is satisfying that condition, and it is printing this. So if you see here in the string class or integer class, we are not doing anything. When you call the equals method, it is though the different objects, but still the content is same. So it is basically it is verifying for the content, and not only the content. Even if I print these two M and N, their hash codes will be the same. Let me print that. Okay. I mean, don't think that this 10 is came as this 10. Actually, that is also hash code. Okay. So the hash code is same. So here it is checking for two conditions. One is the hash code is same, and another one is content is same. When content is same and the hash code is same, then it is treating it as same object. If anything is different, suppose when I say 11, then obviously one is 10 and another one is 11. See, we are not seeing that equals method print statement. So that means this integer classes, I mean not only integer, all the wrapper classes and the string classes, they did something. For example, let me take the same thing for string buffer. This is also predefined class. Now I'll just now here the content is same, but I have created different objects. Now when I print it, what happened? The hash codes coming differently. So that means these string class and the wrapper classes like integer, float, double and all, they did something in their class. So that is the reason when you create a different objects with the same content, it is still generating the same hash code. So that means the objects are same. Whereas in the string buffer, it is though content is same, but it is not returning the same hash code. In the same thing for our class also. For our class, the content is same, but it is not returning same hash code. That means they did something in the string and wrapper classes that something is not happen in the case of string buffer and the same in the case of our class. So what they did, they override two things. One is they override hash code and they override equals method. Okay, so why do we need equals method? To compare the content. Okay, to compare the content. So actually what equals method is doing, it is comparing the content. So now why mandatorily we need to write hash code? If you just override the equals method, so assume that you override the equals method. So equals method is checking for the content. So assume that the content is same. But if the content is same, it will not, but still it will not treat them as a same objects. When it will treat it as same object, the content should be the same, and at the same time the hash code also should be the same. So to make it same, we need to override hash code also. Okay, so for two objects, when the content is same, their hash code also should be the same. Otherwise it will treat them as a different objects. So in our case, that is what happened. In our case, the content is same and the hash code is coming separately. So it is returning. I mean, it is not treating them as separate objects. For example, let me go to this employer class and just override the hash code, not the equals method. Okay, let's see what will happen. Hmm. So if I just overwrite this hash code, which is returning For example, what I'll say, okay. So I mean, don't get confused with the code that whatever I have written here. I mean, just some number, okay. So now I override this. Okay, I'm just adding this override annotation so that it'll consider this method as overridden. Okay, so this is returning some hash code, but I did not override the equals method. Okay, now if I run it, what will happen? Where is that object here? Yes. So the hash code of, now if you see it here, the hash code for these three objects is same, right? For the first, second, third object. What is the first object? Employer obj. Second object, employer obj1. Third object, employer
TreeSet
employer obj2. Okay, if you see here, for all those three, the hash code is same. When the hash code is same, but still how many objects we have? 1, 2. See here we have seen the hash code is same, but still we are seeing the same objects. I mean, it's not the same. Okay, 3, 4, 5. So the hash code is same, but still it is not considering it as duplicate objects. Okay, so because we did not override the equals method, it is treating them as separate objects. Okay, so for all the objects, what we need to do, we have to override hashcode method and the equals method. So if you override just equals method, and if you don't override the hashcode method, what will happen? It will treat them as a different objects. And in other case, if you just override the hash code and if you don't override the equals method, that time also it is not treating them as a same objects. Though the content is same, it is not treating it as the same object. So basically for all the classes, we need to override the hash code and equals method so that when we are adding with the same reference or different reference, if the content is same, then it will treat it as a separate object. Okay, so hash set, what it is doing, it is checking for I mean, if you override it, then accordingly it will check. Otherwise, if you override the hash code and equals method, accordingly it will check whether that object is duplicate or not. If you don't override it, we have seen that what is happening. Even if I just override hash code just to hash code, there is no use. Okay, so let me comment this. Let me comment these things as well. So hash set, what we did, we have added same objects and different objects, and we have seen what is happening with the hash set. Now we will take the same thing with hash map. Let me create one hash map. Okay, so I'll add this. For hash map, it is put. Okay, so what is hash map? What is the error here? Okay, now if I print this hash set, let me command this one. Any other print statements? Okay. I'll comment it. Okay. So what happened first time? It since this is the first object, it returned null. So we have seen this. So what will happen in the case of a hash map? Suppose when you insert a new record, if it is not there, then it will add and it will not return anything. It will return null. And the second time, since that object is there, the same object is there, so it did not insert that. And the second time it is the same object. Content is same, but it's a different object. Right, content is same, but it's a different object. We have added 4 times. 2, 3, 4. Yeah, these 4. These 2 we did not write any print statement. So this obj2, it's a new object. Of course, content is same, but it's a new object. So that is the reason it is not checking for the content comparison. It is just checking the reference. It is a new reference. So it returned null. Whereas for the other 2, it is saying that it is already there. So it did not add it. So that means these 2 and these 2. So total 4 should be there. If you see here, 1, 2, 3, 4. So now we have 4 objects. Now if you observe here, whatever happened to the hash set, the same thing happened to the hash map also. Let me print the hash set. So HashSet also the same object we have passed 3 times, and this is a different and this is different. Of course, this third one, fourth one, the content is same, but it's a new object. But this one we have assigned the reference of the first one, so that means it is same. It means both are pointing to the same object, so it is considering it as same. This is a different object. Content is same, but it's a different object, so it is considering it as separate one. Now, if I print both, both are having only 4 objects. Okay, and if you see the sequence also, the sequence also coming same, but it is not the sequence of what we have inserted. Okay, that sequence, if you take the array list, what it is doing, it is maintaining the insertion order. Like whatever the order that we inserted, it will it will print the same order. It will, even if you print, it will come, the objects will come in the same order. Whereas in the HashMap and HashSet, what happened? The it is printing, it is considering objects based on the hash code value. So the order is maintaining here based on the hash code value. So that is the reason for the hash code and for the hash set, sorry, hash map and hash set, we are seeing the same order, because in both the cases the order is maintaining based on the hash code value. And here also we have seen how it is comparing. So when both the objects pointing to the same object, that time only it is considering as duplicate, but otherwise it is not considering it as a duplicate. But because this is our custom class, but if I take string, but string, though you created different objects, when the content is same, it is considering it as same object, because in our class we did not override the equals and hash code method, so it is considering it as separate objects. Okay, now we'll take the same example for tree map. For tree set, first we'll take it for tree set, and after that we'll take it for tree map. So tree set. Tree set, it is just add method. Okay. Now, if you observe here, what we discussed about TreeSet, that class should override uh, comparable, right? Because TreeSet by default, what it is doing, by default, whatever the objects that we are inserting, by default, it should follow some sorting order by default. So if you take some couple of integers or strings, we are not doing anything, and by default they are coming in some order. That means they have already implemented comparable interface. Now in our employer class, we did not write anything, so that our class should override either comparable, should implement comparable or comparator interface. Okay, because tree set, whatever the objects that we are inserting into the tree set, it has to sort the objects based on some order. Now our class did not implement any sorting. So now what will happen first? It will throw that error. It is throwing that employer cannot cast to comparable. Okay. So now what I'll do, I'll take the same example as comparator. Okay. So for example, I assume that this is taking only the employer. This is the same thing that we discussed yesterday, the other day. So I'm saying on comparator, some E1 comma E2, E1 dot yeah, first let me import E1 dot what I'm saying, if get employer name dot equals of E2 dot get employer name. So what it is saying, cannot convert from boolean to integer. We are not doing anything here. So this one is starting here. So we have this one. Okay, it is saying it has to return something instead of that. So get employer. But we are returning some. But let's see that 1 second. Last time we have seen that in our, where is that? SortedMap TreeSet, I think we have seen that. So what we are doing here? Yeah, we are doing the same right here. Let's see what is the difference. So for employee, when I pass the employee, it is not saying anything. But for employer, it is the same thing. What is the difference? Okay, let's see that. So I have the comparator now. Now when I pass that comparator to this tree set, so when I run it, then that it is not showing that exception because we have explicitly say that okay, this is how it has to sort. Now we sorted based on the employee name. So now if you see here how many objects we have these two and these two because three are same. So let's see how many it is having. Now if you see here, because we did that sorting, if you see here for tree set, only for the first one it written true, even for the third one also it written false, whereas in the hash map or hash set, for the third one it written true, right? But tree set, what happened for the third one, I mean for the fourth one, the actually the object is different but the content is same. Since the content is same, because we have written that, so check if the content is same, compare if the content is same. If the content is same, I mean we are not saying for all the contents, only the employee name. For example, if I give a different name, where is that? If I give the different name for this one, say TCSS, now now it is treating it as a different object, because the employee, though the ID is same, actually if you see, look at the ID is same for both, but the employee name is different because we have written the sorting based on the name, so it is checking for that comparison. So since both are different, so it is treating it as a different object. Okay, now so what it is doing, uh, I think this one, I think it did not check, like we have given comparison for employer, like so suppose if I remove this one, so now I have added 4 here, 2 here, and everything is same, right? Actually one TCS, one TCS. So if I print the size, tree set size, sorry, this actually we printed wrong. Reset object. So what is the size? Sorry, it didn't print the size. Yeah, now it is correct. Earlier we did not print the right one. So actually I have created like new, and I have assigned it. We did it different ways, right? Like I have created with new, and I have assigned the reference, and I have created separate objects. So whatever you are doing, finally what it is doing, it is comparing the content for each object, and based on that it is checking whether that object is duplicate or not. So it is identifying that. So now we see because the content is same for all the different objects that we created. So it is treating it as a duplicate, and finally here we have only one object. So that means what we did here, we explicitly did some comparison. So internally it is calling the equals method. It is checking for equals. So equals method, what it is doing, it is comparing the content. So it is treating it as duplicate objects. So when we say content is same, that means I think internally their hash code is also coming as same. Let's I don't think we can see it here, but if that hash code is not same, though the content is same, it will not treat it as a same object. So I think internally the hash code is also, it is setting it as, it is showing as same. Okay, so and if you observe the difference between the tree set and hash set HashMap HashSet, uh, it doesn't require to explicitly implement comparator, or if you don't want a comparator like this, that class has to implement comparable. At least that class has to implement comparable, or we need to write comparator. Otherwise, the object itself we cannot add. So that means if we are taking tree set, you are you are indirectly doing the comparison for equals method and hash code method, whereas that is not case with the hash map and hash. So in order to do the comparison for the objects, that you need to explicitly override hash set sorry, you need to explicitly override equals and equals method and hash code method, whereas in the case of hash set tree set, it is we are doing it explicitly through comparator. Now this, let's take the same thing for tree map. Okay, first I'm not adding any comparator. Yeah, tree map, it's a map, so it is key value pair. Let's take integer. Okay, so now, so if it is a tree map, then it is a put method. 1, 2. On the outside. So now same thing, the way that is working for tree set, even for tree map also, it will throw that error because I'm not either my class is not implementing the comparable interface, nor I'm not explicitly passing the comparator. So it will show that error. The class employer cannot cast to the comparable. Now if I pass the comparator, so now if you observe here also, it is just taking only one object, that is last object. Whereas if you see the hash map or hash set, suppose if it is a duplicate object, what it is doing, it is just adding the first object, and all the other subsequent duplicate objects that we are adding, it is not adding that. Whereas this one, what it is doing in the case of tree map, first you add one object, and next time when you are adding duplicate object, it is removing the first object and after that placing the next object. And third time when you are adding another object, duplicate object, then it will remove the second object. Then so only whatever the latest duplicate object that you are adding, the latest object is there. Whereas in the case of hash map, hash set, it is not the latest, only the first object will be there, all the subsequent objects will not get added. So that is the reason we are seeing 6 here, and that means this is the object. Okay.
Okay, sir.
So yeah, these are the different cases with how it is behaving. Actually, if you see here, ever did we change anything? It's the same code. We just were adding the objects, but the behavior is different. And to get that behavior, we now we know what we need to do. Suppose if you want to add some objects to HashMap or HashSet, and if you want it should not have duplicate objects, then what we need to do? We need to override that class. In that class, we need to override hash code and equals method. If it is a tree map or tree set, I mean it is mandatory. It is mandatory to override to pass some comparator, to implement comparator or comparable. So if you take tree map or tree set, it is mandatory. You cannot add without implementing either comparator or comparable. Whereas in the case of hash set or hash map, if you don't override, then it will treat it will allow duplicate objects, but not directly, in a different way. I'm directly in the sense, if you assign one reference to another reference and if you pass those two references, in that case only it will treat it as duplicate. Otherwise, it will treat it as separate objects. So if you don't want duplicate objects when you are adding objects to hash map or hash set, then you need to override equals method and hash code method. Otherwise, you will see duplicate objects with duplicate content. So I mean with the same content. Okay. So yeah. So in the next session, we will see some other classes and interfaces.
Okay, sir.
Okay. Thank you.
Thank you, sir. Bye.
Bye.